Welcome back, serious DIYers and fabricators, to This Explainer. Today, we are bringing you a full-on masterclass on treating one of the most resilient and, yeah, let's be honest, expensive materials in your workshop exactly the right way. If you have ever ruined a beautiful sheet of polycarbonate because the edge just melted into a gummy mess, or maybe you're gearing up for your very first big project with it, you are in the absolute perfect place. We're going to break down exactly how to achieve clean, professional edges every single time, straight from the experts. But real quick, before we get our hands dirty, I want to give a shout out to fidarsystem.com. If you're looking to place an order for your next project, definitely go visit their site. They offer custom sizing, which is super handy, and they sell ACM, acrylics, pastel, polycarbonate, and a whole lot more. Plus, they offer free shipping on your first order and on any order over $700. Of course, terms and conditions apply, but be sure to check them out for all your material needs.
Okay, let's dive into this. Here's a quick look at our syllabus for today. First up, the shop floor perspective. Then, why polycarbonate isn't acrylic. 3. Circular saws versus jigsaws. 4. Essential workshop safety habits. And finally, 5. Step-by-step edge finishing.
Starting right off with Section 1, the shop floor perspective. To make sure we're grounding these techniques in reality, we're pulling from the real-world, hands-on experience of James Parker. He's a Red Seal certified fabricator with 15 years of practical experience cutting and shaping these exact composite panels. He puts it perfectly when he says, polycarbonate is tough enough to stop a hammer, which is exactly why it fights a careless blade. And you know, that really is the fundamental conflict here. You're working with a material designed specifically to resist extreme impact. If you treat it like a regular piece of plywood and rush the cut with a coarse blade, the friction will literally melt the edge into a fused, ruined bead. But if you respect the material, it cuts beautifully. Moving right along to Section 2, why polycarbonate isn't acrylic.
Now, a lot of you are probably super familiar with the popular score and snap method used for acrylic. You score a line with the blade, apply some pressure, and the acrylic, which is naturally brittle, just fractures cleanly right along that fault line. Super satisfying, right? But listen, if you try that score and snap workflow on polycarbonate, it's going to fail miserably. Instead of snapping, the polycarbonate simply bends, and it leaves you with a torn, jagged, completely useless edge. It all really comes down to impact resistance. Get this, polycarbonate is up to 30 times more impact resistant than acrylic and a staggering 250 times stronger than glass. The very reason you're buying polycarbonate in the first place, its massive, unyielding strength, is exactly why scoring and snapping is physically impossible. You absolutely must cut polycarbonate all the way through with a saw or a router. Period. Which brings us to Section 3, circular saws versus jigsaws.
When working with this stuff, matching the tool to the cut is everything. Your circular saw is going to be your absolute workhorse for those long, straight cuts. You want to set your blade depth so it clears the underside of the sheet by only a few millimeters, because that really helps keep the heat down. On the flip side, the jigsaw is your go-to for curves, circles, or interior cutouts. But here's a massive pro tip for the jigsaw. You must set it to a low or completely zero orbital action. Aggressive orbital motion will just grab that soft plastic and leave a ragged, terrible line. And honestly, if you take nothing else away from this whole tools section, remember this number, 60 to 80. Whether you're using a circular saw or a table saw, a fine-tooth carbide blade with 60 to 80 teeth is the magic secret. Please do not use a coarse 24-tooth framing blade meant for wood. A fine carbide blade, the kind of self-recutting laminate or aluminum, keeps the heat down, ensures a smooth edge, and prevents the plastic from melting and literally refusing behind the blade.
All right, jumping into Section 4, essential workshop safety habits.
Having the right blade is only half the battle, guys. Let's run through the top 5 mistakes that send people right back to the store for a replacement sheet. Number 1, we already mentioned, coarse wood blades. Mistake 2 is feeding the saw too slowly, which we'll unpack in just a second. Mistake 3 is a total classic, peeling the masking film too early. People strip the film to, see what they're doing and then immediately scratch that pristine surface, dragging it across their workbench. Keep that film on. Mistake 4 is drilling tight holes, and mistake 5 is cutting unsupported sheets. If your sheet overhangs the bench, it flexes, it chatters, and it inevitably chips. Always support both sides of the cut line.
Let's look a bit closer at mistake number 2, feeding too slowly. When cutting polycarbonate, hesitation is your absolute worst enemy. That blade is spinning incredibly fast. If you push the saw too slowly, the teeth stop cutting and actually start rubbing. That rubbing creates massive friction, heating up the cut zone until the plastic turns into a liquid, gummy mess that welds itself back together right behind your blade. You literally have to cut it twice. You need to feed the saw at a steady, confident pace, just like you would with plywood, letting the blade clear its chips.
Now let's address mistake number 4, drilling tight holes. Polycarbonate expands and contracts with temperature shifts way more than glass or metal. Just look at a 60 degrees Celsius seasonal temperature swing. That's very typical for a Canadian workshop going from a freezing winter to a boiling summer. A 10-foot panel will physically stretch and shrink by almost 12 millimeters. If you drill a super tight mounting hole in July, by February, the shrinking panel will pull against that rigid bolt and it will crack the entire sheet. Always drill your holes 1 to 2 millimeters oversize.
And finally, Section 5, Step-by-Step Edge Finishing.
Okay, so even with the absolute perfect blade, a saw-cut edge is going to have some light burrs. Here's the professional cleanup process to deal with that. Step 1, gently knock off the sharp corners with a fine file or a deburring tool. Step 2, grab some 120 grit sandpaper to knock out those visible saw marks. Step 3, step up your grits to 240 and then to 400. And finally, Step 4, finish it off with a 600 grit wet sand. Now we should set some expectations here. Polycarbonate tends to hold a smooth satin edge. It doesn't easily buff back to that water-clear optical finish like acrylic does. But honestly, for most machine guards and signage, this satin finish is absolutely perfect.
Now, some of you who work heavily with acrylic are probably looking at your screens right now and thinking, wait a minute, what about lasers? What about flame polishing? Why am I doing all this sanding? Well, it's because a laser is literally the absolute wrong tool for this material. A CO2 laser cuts by burning, and let me tell you, polycarbonate burns terribly. If you put it under a laser, the edge won't be clear, it'll come out discolored, brown, and rough. And worse than that, the process releases incredibly harsh, toxic, and acrid fumes that are terrible for you and terrible for your workshop's extraction systems. Major polycarbonate manufacturers strongly advise against it, so stick to mechanical cutting, routing, and wet sanding. Trust me on this one. Well, we have covered a massive amount of ground in this explainer today. From avoiding that dreaded melted edge with a steady, confident feed rate, to choosing those crucial 60 to 80 tooth blades, to really understanding why you must never treat this incredibly tough plastic like brittle acrylic. You now have the shop floor knowledge to handle this premium material without fear. So, I leave you with this. Armed with the right blade and a confident feed, what are you going to build next? Get out in your workshop and put these skills to the test. Thanks so much for joining me today, and I'll see you next time.